So let's start. Hi, everyone. So welcome to our bootcamp, CorDapps for Capital Markets. And I'm Irina from R3, the company behind Corda, who designed and developed Corda DLC. So I will be running this session today, and David Awad, my colleague, he will be watching the chat and answering all the questions from you. So feel free to post any questions in the chat, in the Q&A, and he will answer as soon as possible. So let's begin our session. So first is let's see the channels for learning and communication, where you can find all available content and information, and also communicate with other developers. So this is our YouTube, Corda blockchain, free. You can find free training on Corda.net. You can find also documentation and docs.coda. All samples are in the GitHub repository. We have as Java, the same as the Kotlin samples. You can find all our developers chat and I'll use together at Slack. You can also ask questions there and we will answer. You can tweet us at Coda blockchain with the hashtag Coda and hashtag R3. Or if you have any particular questions or inquiries, you can email developer relations team at r3devrelations@r3. So let's start. Themes R3 is focusing on capital markets is primary assurance. So let's first kind of go and see what capital markets means. This is referred to places where savings and investments are moved between suppliers of capital and those who need those capitals. So example of capital markets is an organized market in which both individuals like you and me or any companies, businesses can buy and sell debt, which is debt of a company, which is a bond market, or equity securities. Equity is the shares of any company, like big IT companies or anything. So this is two basic markets. Like an umbrella of capital market, which is bonds and shares. So the first one is primarily issuance. So this is the most initial, the first example of Coda in capital markets, where you can issue assets on the ledger. And for this, you can use our tokens SDK. This is toolkit and library that Corda R3 developers build specifically for you to use and to utilize these amazing features. Direct asset transfer for faster clearing. So basically moving assets between two parties, two businesses or individuals on the Corda. And so faster clearing, the whole process is usually very manual. If you do it on Corda, it just takes for you milliseconds. It's basically instantaneous. And so what's this primary assurance and direct asset transfer is is different from the previous ways of doing processes on capital markets. We are using when you use Corda, you optimize cost and time. So it's faster, it's way cheaper. You don't need that much headcount to do it. So it's super efficient. And the last application of Corda is a payment and settlement. Let's be a bit kind of stop here for a second. Payment is a component of a settlement in the capital markets. So, and settlement is a component of a post trade, and the post trade is a part of market flow. So this is after you do your trade, after you buy shares. This post-trade process includes settlement, and inside settlement there is a payment. So what is the settlement? Let's kind of, to make sure that we all understand what we are talking here. This is a process in which a buyer makes a payment and receives the agreed upon like goods, in this case, this like shares. And this term is usually used like in exchanges. So we have like examples of Spunta, which is Spunta is a DLT solution that's built on Coda enterprise, and is governed by Italian Banking Association, and it's now live on over 100 of Italian banks. So it represents of like more than 90% of all national banks. So we have like NASDAQ, another great, super great example. It's so they're offering digital assets exchanges on Corda, and Contru, which is a digital trade network, and that use Corda as well. So today we look at the example, the most kind of pain point for people in the capital markets, which is a due diligence and information sharing. So let's kind of first, again, try to understand what due diligence means. It's an like investigation or review that performed to confirm some like certain facts and of a business, of a company. So for example, due diligence examples would be businesses, like for example, businesses examining and auditing, which so another way of saying it, another company to determine if it's worth investment or IPO, or even lending some money from we, like both of us, doing due diligence basically on every day when we reading reviews before buying something online. So this is due diligence. So you want to make sure that the item you're buying is worth the money. And also we do like check like our bank accounts and credit cards frequently to make sure that there is no any unusual transactions. There is so this is all like due diligence. And so the problem that we are looking today is in the due diligence in the capital market. So whether like big banks involved, and and this is like common for like any investment. And there are a lot of like a trust required between those parties, like those banks and the company. For example, if CEO is trying to raise money, like another investment fund and another investment round, and imagine this scenario: there is like two companies who are looking like for investment. So it's two banks, Bank A and Bank B, and they both want to do this like due diligence, like auditing this startup that want to raise money. And also we have a regulator who knows which are audits who provides this like due diligence are trustworthy and not trustworthy, and they provide this like white list of trustworthy audits. So, and using Corda, we will see how those banks can collaborate between each other, and they can share trustworthy information. So let's look at like our example. This is like CorDapp that we're going to look today, and so these companies want to share like trustworthy data, and they want also to kind of, but obviously like no banks don't trust each other by default, so they want to make sure that there is some kind of checks of being like of providing like honest or auditing like reports. And we have this like regulator who will provide this like list of qualified audits. And this is how the Corda comes, that all these like banks in one network, and they ask auditors for this information for these reports, and how they can banks share those reports between each other, knowing that those reports done by approved regulators. So this is like a very common problem in a finance world, in the capital markets, because usually it's all done. People call each other, people send emails. This is very, very slow process, very laborious process. When by then banks exchange those reports, it's really hard for them to understand if they can trust this data or not, because they don't know which audits they used, if it's safe to use, and if other banks using the same data as they share with their participants. So in reality, this is like very laborious and very slow problem. And with the Corda, this can be like basically the whole process can be optimized and done in like milliseconds, and it doesn't require those sorts of like stress that people have every day. So let's see. And so this is the problem that we will share. But before that, let's look at the like Coda and what is a Coda. And like I like already mentioned couple of the definitions of Coda Network, and let's kind of like look like very high level at it, like at very simple levels, so we're both on the same page. So it's useful to imagine Coda as a fully connected graph where all nodes on the graph are actual Coda nodes, and each node is an actual representation of a business, of a bank, of a startup, of any legal identity. And each of them runs those like software, and Coda software, and also the CorDapps, which is a kind of like smart contracts on Corda. And every developer can create these CorDapps, and I will explain like a bit later the main components and how easy and straightforward it is to write. So on like these CorDapps, the ages between like A and B and C are actually the kind of representation of a communication, so you can directly communicate with any other banks. And all of the nodes in the network have a potential to communicate between each other, so as long as you can see all other nodes, you can send information to them, you can exchange information, send a message, or like contract, or whatever information you want to send. And I want to stress that this is a point-to-point communication. So this means that this data shared on a need-to-know basis. So this is done by design. So because security is the top one priority, so only parties, only banks that are involved in transaction would know about this, that this transaction was happened. But if you want to broadcast it to everyone on the network, if you want to send it to C, to party C, to bank C, you can still do it. So, but this is no default way of sharing data on Corda. So this is like very crucial that we don't use like gossip and network to propagate data. We don't broadcast data. This is Corda uses like point-to-point messaging. And also want to stress that there is no single central store of data. So instead, each node has its own database, which is called Vault, and that database stores all the facts, all this information that was aware of. So the facts that nodes know about are those that this node has been involved. So if bank A had a transaction, had some sort of business with the party B, so they will only know about those transactions. So also there is like a good example with like Alice and Bob on the network, where Alice loans some money to Bob, and both Alice and Bob will know will have identical information about this loan, and only them will know about this. Like if there is Charlie on the network, he won't have a clue that this loan was happen, this kind of business will happen between Alice and Bob. So there is no central node that stores all the data or everything from the network. This is like a biggest misconception that with Corda that people often think, but this is untrue. And also we have a node tree. So a node tree pool means that you can have also like multiple node trees nodes and not just like single one. And so we'll talk about it in a second, what node tree is. So let's look a bit closer at the Corda node. So this is Corda node, which has, which I mentioned before, that where the node represents a business identity, so like start a bank or whatever. So what is it inside? Like, let's like quickly look at it, like very simple terms. So it's Corda node runs a Java virtual machine, and there is a mechanism for nodes to discover each other. And this is this mechanism basically like a list of all nodes on the network. So all the benefits of DLT properties are made simple by abstracting them away. So all those things you just like, you can abstract it. So you as user just like very simple, like very straightforward Java code. And there is as a CorDapp developer, you can get all information through like Service Hub, which is here. You just like basically ask for like Service Hub, and it has like all properties and all functionalities that you need to interact with a within the network. And also, so it's abstracted by quite a lot of the complexity, like the whole node. So you don't need to see it. And let's look at the next slide, which is a node tree. So you saw this like node tree before. So node tree clusters, like the main purpose is to prevent double spans. So the first, this is the first and the main problem that all digital assets and cryptocurrencies are facing, like double spans. And so there is like one obvious question. If data is distributed on need-to-know basis on the network, how do we prevent like double spend? So one, like digital dollar is not spent like twice. Digital like digital share is not appears twice and with the two owners. So this is how do we prevent this? We prevent it with the Coda node tree. And node tree clusters are also provide like timestamp authorities if you want to make sure that your trade has been done within like certain like time window. You can do it with utilizing node tree, and it also validates all the transactions. So let's kind of now move to the CorDapp. So CorDapp is like smart contract. It's a decentralized application, and so decentralized applications it's application that runs on distributed system, and sometimes it's referred to smart contract. So we call it CorDapp, Corda decentralized application, and so it's a very simple like binary jars that are stored inside this like Corda nodes, and there can be like several Corda nodes on several CorDapps on different nodes. And let's now move to the next, which is components of CorDapps. And this is actually kind of CorDapps is also application, and this is so previously we were looking at the Coda Network and like hardware. Now let's look at how to build a CorDapp. So it consists of 3 components: flow, state, and contract. So flow is executing business logic. So all calculations, all verifications, signing, like data writing to the databases, which we call like vaults, are executed on flow. You can think of it as your function in a Java. And we have states, which are basically objects on Corda that can that are shared fact. That basically those shared facts that you share with other banks, or those auditing reports. This is like a shared fact. All those are called like states, and those states can be consumed, they can be updated, and they can be stored. So, and we have contracts which are verifying the transaction, and this is agreed upon rules that users can change the state fact that are involved over time. So, we have these three main facts. So let's look closer at flow, which is here. So flow, as I mentioned before, this is you can think of it as like your function, like a main function on C++ or Java. So this is what we have. This is where you can start writing your code, your business logic. This is like entry point. This is the first part where you start your CorDapp. And the difference with as I mentioned, you can think of it as a main function in Java, but the difference is that you can have many these flows. So steps in the flow reflects the business logic of your CorDapp, of your smart contract that you want to execute. And so since we're in a network, the main purpose is to communicate with other nodes. So with the flow, you say when you want to communicate, what information you want to communicate with, and who you want to communicate with. Like, do you want to send it to party A and party B, or to Alice? So developers can quickly accomplish tasks and write the flows using extensible like flow library that is available, that performs like standard tasks. So it's very simple and very easy to sign transaction, to send it to other parties. Is just like a very, very, very straightforward. Let's move now to the state, to this like information that we share. We have again example with the Alice and Bob. So state is state, as I mentioned, is that shared fact that we communicate with the other parties. We call it in Coda state, and this is a like typical use case for Coda is to allow different organizations like to message each other, to transact with each other, and this is what they transact. This information is a state. So this is piece of data that doesn't exist in a central repository because there is no central repository in Coda, but exists in all nodes that participate in this transaction. So as we see here, like if Alice and Bob, Alice lends Bob like $10, and this is the state one, only they're aware of this state, no one else is aware. So you can think of it in a kind of an event diagram. This is a very kind of clear way of understanding it. So, and also on the example of like issuing assets, here we have a token state, which has some like properties in it. So it's basically like a class. It is a class, and it has like issuers, owners, and amount of tokens, the tokens that it has. So it's this is how we share information, and this is our like objects that we want to represent digitally. So let's now look at the contracts. Contracts is a kind of a digital representation of the contracts that they used to have like between banks. Now there is like a digital representation of it. and this contract runs transaction against its rules and checks. And here, let's just like have a quick look at this like diagram and understand that this is basically any update on the vault, on the like ledger, on this like database that you want to do. You do through these like transactions that you put that you kind of program on your flow, and contracts verify if it's successful, then it's database, like your vault is updated. If it's not successful, then it's not updated. So any transaction has a input and output, almost any transaction. So you can have like 0 inputs if you're issuing something, but let's look at this example. You have existing state and you want to update the state. So you put it like existing state and you create like output state that you want to, so this input state will be consumed and this output state will be like a new state that will be updated on your ledger. And the contracts run like all the rules, and all rules need to be successful. And only after all the rules are successful, this transaction will this state, like new output of this state, it can be written on the ledger on this like vault for all these parties that are involved in this transaction. So let's look at another example where we have a failure. For example, here we have the same input and output, but one of the rules one of the rules that were assigned to this transaction, to this contract, the transaction didn't meet one of the rules. For example, if Alice lends money to Bob, lends $10, and so it's put here, the owner Alice as an input state, and the output state will be Bob is owner of this $10. And what we have in a kind of in a successful, the output will be like Bob owns now $10. In an unsuccessful, for example, if Bob writes that he owns now $100, so he just like issued himself like money, which is you should have always the same amount of input, the same amount in output if you like sum all money together. So that's one of the reasons how you can how the contract can fail, and then this means that the transaction is rejected, and it's not being like signed by Alice because she owns like $10. She lends $10. She doesn't want to like to see this like shady transaction. So this is the way how it can fail. Another example of like issuance of transaction. So when you issue money, like when, for example, central bank, which is the hot topic right now, when they issue like CBDC, like digital money, digital currency, so then they will put the amount. Input is 0 and the output is this like token, those like digital money. The contract will need to check that the amount is positive, so you cannot issue negative amount of money. So, and also in the transaction, how it checks, it has this command. So if command is issuing, then amount should be like larger than amount should be positive, and there should be 0 inputs. When you have a command update, then you, as we were looking at the previous example, for example, here command update input. So then it will, contract rules will run contract will run different rules against like different command. But since contract have to have different rules for different commands in the transaction, and this command we need to give a kind of hint to a contract which rules to run against a different transaction. So what we are looking today, so we went through our let's Yeah. So we learned about how to write like CorDapps, like very high level, that CorDapps consist of flows, which is basically your, where you put your business logic, where like your functionality, state, this information that you share between parties, between banks, and the contract, which are basically a set of rules that you run against any transaction. And we also learned about Coda Network. Where is that? Like this one, yeah, it's just a Coda Network, how it's like a very high level, so we can, but this is enough for us to understand and to look at examples. So Coda Network consists of like all these Coda nodes, and each Coda node represents a business identity, and it just means a potential of communicating, so it's like full so it's like fully connected graph, and it means that there is no also single storage of data, and you need to know with whom you want to communicate. You don't broadcast by default. You need to, or by default, the communication is done on a need to know basis. There is no broadcast. So let's look at our example. So we kind of like, we have like very simple, clear understanding of what Corda Network is and how to build like smart contracts, what it consists of. The smart contracts consist of a flow, state, and a contract. So let's look at our example, the due diligence CorDapp smart contract that we built specifically for this bootcamp for you. So in our example, we have like two investment firms, like Bank A and Bank B. You see that this is all very similar to our previous like Coda Network, right? So we have Bank A and Bank B. Investor doesn't need to be on the network. Not investor, the startup that where these two banks wants to invest. And we have like auditor, like trustworthy auditor appointed by the regulator. And we have also the regulator who will provide this like whitelisted auditors, like trustworthy auditors. So each of these parties are able to communicate with the auditors and regulators and the investment company, and of course, like each other can share data, what they learn, but they want to make sure that it's trustworthy. And let's look at the example. So how are we doing it? So we have these like stages, like steps, how the due diligence is done on Corda. So we have like a Bank A is creating this request to the auditor to provide certain information on this startup that they want to invest. So the auditor validates and approves the auditing request. So this is very simple, kind of high-level smart contract. In reality, auditor needs to provide some information. Here we will just kind of like validate, and in the production CorDapp, auditor would have need to put some information about this startup before sending it back. Later, the Bank A is sharing this report, the auditing report that it received from the auditor, with Bank B, and it's only if this report is produced by a whitelisted company, so by whitelisted auditor, which is provided by regulator. And then both this, like Bank A and Bank B, submit their due diligence checklist to regulator, and then a regulator can have all this information by the like, account form and so on and so forth. So let's see. So this is only like one part of this main picture, that main diagram that we learned before. So this is like corporate auditors. We will give you a chance to look at this CorDapp, and if you want to implement financial auditor and taxes auditor in your like free time, and please like let us know how you're doing with this. So it will be like very straightforward once you learn corporate auditors. This is the same steps, the same smart contracts, but it's just like for financial and for tax auditing. So we look at only at like this small example today. So let me share my other screen. So I'm sharing with you. So the due diligence Corda, this is what we are looking, the example that we are looking today. So here we have our whitelisted corporate auditors, which we put in a jar, and then we need to run it over with regulator need to provide these whitelisted companies to all banks in the network. So this is done by running this command, which is greatly upload whitelisted companies. I've already done it, but let me like stop it and redo it again, so you can see it. So I'm running all commands. So I'm deploying the nodes, and then we will issue it on the ledger. I will, what I will do. I will show it. I will share my whole screen, so this way it will be easier for you to see. So you see my screen now. I have our diagram here, and I will walk you through how we how the communication is happening from the on this due diligence CorDapp, and what exactly is going on here. So now we're deploying the nodes. And now let's run them. So now we're running all the nodes, and we have all terminals. Like each tab is open for each node. And let's see on the builder grade that what nodes we have. So we have notary. We have bank A. We have bank B. We have our trusted auditor and regulator. So we have this, like all parties, this is the minimum parties that we need to run this due diligence command. So let's now make sure that we so bank A, regulator, bank B, and auditor all here. So let's so the first step is at party A, like at our like bank A, we'll need to request to validate corporate records. We need to, like bank A, we need to send a request to auditor. So this is usually done with a start request to validate corporate records, and then where you send it to trusted auditor, and then you put the number of files. This is very simplified. Usually there are way more the request is way more difficult to than this. So we need this case ID, we need this ID for our other for future references. And let's see what let's run a query and see vote query on the contract and see if we receive something. So we have the qualification false. It means that this contract, this record is not qualified by auditor. So we need to get this approval from the auditor. So how we get it? We go to our trusted auditor, and we run the auditor validates these records on the trusted auditor. And we also add like linear ID, that's exactly linear ID that we got from bank A. And this is the point where auditor usually provides the whole information on the startup that bank A wants to invest money, and put it all together in a transaction. Like this is the state. This is all this information that bank A requested, like those auditing reports. And now we can see in a bank A, we can run the vote query again and see that it's still false. Let me run this. Let me make sure that we got the same information. So we have case ID. Now it was everything. Okay, it's done. So the validation is completed. Now we will instruct party A to share this copy of auditing with the bank B. And this is, so the parameter that we use to share this information with the bank B is exactly the same case ID. And so in order to share this auditor, we need to send the whole information. So we share the auditor results. Let me try to make the. So it will be easier for you to see. So we're sharing these auditing results that we got from trusted auditor. We put the this case ID of this report, and we send it to file bank B. We also add the hash of the attachment for this report. This was like pre-calculated. One second. So I'm running into errors. David, if you have any ideas what's going on here. So this is so this is most probably because the hash is not calculated correctly, and
I would say maybe it might be easier to jump into the documentation. We've all been burned by a live demo before, but if you've got the repo up, maybe it's easier for us to refer to that to show people how it's intended to function. And we can kind of double over this after. Hopefully we can save some face here. Certainly not the first live demo to not pan out the way we would hope, but might be easier to reach for the documentation here since we've written it up already and we've run it before.
Yeah. So in this point, we are sharing information via bank A and bank B, and then so this information with the attachments, and so the bank A would now create a checklist and send it to approval to the regulator. And let's see if we can have this. If bank A can send this approval to bank to the regulator. Okay. So yeah, so it's provides some verification errors again. So let's assume that we send it to regulator, and then regulator has information on both of these transactions. We did run it before, and it was all correct. Let's now. I think yeah. Let's now move to the. Is there any questions, David?
No, we're all good so far.
Yeah. Okay, yeah, so we will create probably like UI for this CorDapp, so it will be easier to visualize. And yeah, thank you so much for listening to our due diligence examples of Corda in capital markets. And please, if you have any questions, please ask. Otherwise, thank you so much for watching.